I request our friend Priti here to present to us on the topic nuclear waste management. Now the floor is yours, Priti. Please deliver the presentation.
Thank you, sir. Good afternoon, everyone. My topic for presentation is nuclear waste management. So, first of all, abstract. Nuclear power can replace fossil fuels and will have a decisive impact on the change in the approach to conventional energy. However, nuclear wastes are produced by the operation of the nuclear reactors should be safely and properly disposed of. This paper assesses the uranium resources and the global state of nuclear power plants and determines the energy mixes in different countries using the most nuclear energy. Furthermore, this paper analyzes the nuclear waste management and disposal and the definition of abiotic resources and the primary energy sources of a basic production process using electricity mix and nuclear electricity for a basic production PET water manufacturing process. The life cycle assessment was completed by applying the GABI 8.0 software and the CML method.
Thank you, Priti. The way Priti is presenting to us is very clear. The voice is crystal clear and audible, and thank you for being very clear. The uranium fuel resources worldwide are analyzed. The resources of uranium are analyzed, and life cycle assessment of the nuclear fuel is made, and nuclear fuel waste, how to manage, advice has been given. Methods of managing the nuclear waste, suggestions for managing nuclear waste has also been given, which are useful for the nuclear industry, especially nuclear industries like Kalpakam, Kalpakam, and Baba Atomic Research Center in Mumbai, and Kaiga, it is called National Thermal Power Corporation Limited, NTPCL in Kaiga. Okay, likewise in every state we have nuclear powered electric generation installations. All those things, all those industries are benefited from such research in nuclear waste management. When I asked my friend working in Kaiga nuclear power plant what are the strategies they follow for nuclear waste management, he recommended me to browse through BARC, Baba Atomic Center website. Yeah. That is good idea. Yeah, that will be ideal. That will yeah. This is a good advice. Please go ahead.
So next is introduction. Fossil fuel resources, natural gas, oil and coal, including hard and brown coals, do not have substitutes that can meet the current energy demand. However, at current production levels, documented reserve of oil, natural gas and coal will be sufficient for 51, 53 and 153 years of operation respectively. For nuclear energy based on uranium fission and uranium from reasonably assured resources will suffice for less than 100 years at the present market price. For example, no more than the fossil resources, but it could be available for several thousand years if recovered from seawater, albeit at a much higher price. In the same spirit, uranium from reasonably assured resources could suffice for tens of thousands of years if the present thermonuclear reactors were completely replaced by a fleet of fast neutron reactors. Therefore, we need to create a stable energy portfolio if we are to meet the future demand for clean energy. In any case, the future energy portfolio out to efficiently adapt to alternative energy resources with renewable sources, wind, solar, biofuel, etc. poised to replace coal, oil and natural gas. It should also consider providing access to those without the electricity and those whose recent developments have created the potential for clean, sustainable and renewable energy in some countries. Renewable energy Reducing energy demand in the short term is an important element of cost-effective mitigation strategies that provides more flexibility to reduce CO2 emission in the energy supply sector. According to the baseline, scenarios assessed in year 5 direct CO2 emission from the energy supply sector will almost double or triple by 2050 compared to 15.4 GT/CO2 per year in 2010. So material and method. So first is data research method. This manuscript is
Excuse me, Priti. You know, when I listen to Priti's presentation, it's reminding me of attending, an international symposium, or a PhD scholar's presentation. Yeah, her presentation and her way of, delivery is like, typical expert research scholar. I appreciate, you have much talent, and I only assure you that you need not fear for the exams. जो कुछ भी मटेरियल आपके पास है, concentrate. Yeah, the time is limited, I agree. As far as my part is concerned, there is a book by energy sources. Okay, I uploaded in the classroom. In that, different energy materials are there, energy sources are there. I will also send that through WhatsApp. Okay, spend some time in reading that book, introductory part, that will serve to answer my questions. Also, I will give you a blueprint, or a outline of the question paper, how it will be. I will discuss with Aditya sir, and I will try to give you an outline of the paper. Okay, please, Priti, go ahead.
So data research method. This manuscript is partially based on primary literature data and partially on secondary industry data from Gavi 8.0 life cycle assessment. This review follows the lengthy literature review we published that covered data from the following sources: World Nuclear Association, International Atomic Energy Agency, Power Reactor Information System, and the European Commission. In calculating the electricity grid mix to represent using bias charts from different countries, we used specific information from the Gavi 8.0 life cycle assessment software. The related life cycle inventory includes and quantifies energy supplies for all the countries examined. The data set for the electricity mix is an annual average in 2021. Second is life cycle assessment method. One goal of this research was to determine abiotic depletion as an environmental impact category and primary energy resources for the production of life cycle of polyethylene terephthalate products using a professional data set. After quantifying the abiotic
Excuse me, Priti, एक minute. PET, polyethylene terephthalate, how is it related to nuclear waste? Where are we using PET in nuclear industry? I am not aware. Please go ahead. This is a question, you should be inquisitive. My objective is to teach you how to question. Okay, when you see something new and you see that you do not know, you should question so that you will learn. Okay, go ahead, please.
So after quantifying
Excuse me, we may not have answers for all the questions, but it should not suppress the spirit of questioning. A child, when he sees some new thing, some new plant, some new fruit, वो बेटा उनके पापा से पूछता है, पापा ये क्या है? That is how we have evolved. That is how we have known. No, if we do not know something, we are supposed to learn from our teachers. That is why we are here. Please go ahead.
So after quantifying the abiotic resource depletion, the life cycle analysis was conducted using Gavi 8.0 software. Modeling of
Excuse me, for your kind information, I am listening of this Gavi software only today. This is new thing, okay? 20 years of research experience. I am not expected to know all. What I know is only a drop. From that I am telling you. What I want to convey you is, do not think that you are forbidden to learn new things. You should be open to learning new things from literature. Gavi software. Till now I do not know that such a software is available to life cycle assessment. I read many papers on life cycle assessment. Okay, life cycle assessment of biofuels, biodiesel, bioethanol. Okay, many fuels. But I have never ever heard that there is a software called Gavi. That is a new thing Priti has brought to us. We should appreciate her. I really do not know what it is, but Let us see if we can learn something. At least Gabi, it is there. I can go and search, if I want to do some life cycle assessment calculations. Please go ahead, Preeti.
Modeling a plastic product requires the use of product-specific input data. The life cycle inventory method includes and quantifies the input-output material flow and the energy requirement of unit manufacturing. This methodology divides the energy requirements and environmental emission between the PET products produced by mass allocation. The data set for polyethylene terephthalate corresponding to the EU average. The inventory is primarily based on industry data from internationally relevant production processes. During manufacturing, we assume no manufacturing loss. Output was used to determine the abiotic resource depletion and primary energies of 4 kg of PET using the CML life cycle impact assessment method. We determine the abiotic resource.
Excuse me, Preeti. Have you heard many a time we are listening abiotic? This is opposite. This is opposite to biotic. Biotic means that is natural. Abiotic means not naturally generated. For instance, PET. How PET is generated? Is it available naturally? We have to make PET. Okay. Such materials that are synthesized by man are called abiotic. Biotic are naturally available materials. Okay. Please go ahead.
During that data analysis, the reference system utilized the electricity energy inputs for each country. We didn't use normalization and weighting to calculate the
Weighing
to calculate the
there T should be silent. Weighing machine, weighing balance. Okay, go ahead.
of impact category indicators. So result first is uranium resources and uranium production. The exact processes of nuclear fuel or spent fuel differ depending on the nuclear fuel cycle technologies utilized. Currently, single and dual fuel cycles are the primary strategies. The once through cycle, direct disposal or open cycle, and the twice through cycle, recycling or partially closed cycle. Based on these, nuclear fuel production cycles for both technologies include natural uranium extraction, uranium mining and mining, conversions, and increment. The nuclear fuel fabrication cycle for both technologies include natural uranium mining and mining, conversion,
Mining and milling.
conversion, enrichment, and fuel fabrication. Figure 1 shows the mass flows during nuclear fuel production.
Excellent. Excuse me, Preeti. Here in the slide that Preeti has presented, you might have heard of two vital things. One is nuclear spent fuel. Nuclear spent fuel means once the fuel rods are consumed, the spent material will have many fission fragments. No. Do not be hurry. Take time to learn. Please do not push. Preeti is delivering her best. Some missing links I am providing you. Spent fuel. Apart from spent fuel, Preeti has introduced to you another important point, what is called fuel enrichment. Nuclear fuel enrichment means isotopic enrichment. Naturally occurring uranium has majority of uranium-238. Okay. Enriching means increasing the content of uranium-235 at least to 2% or even more. As I know, the naturally available uranium contains very little of uranium-235. 0. Let me see. Yeah, please go ahead. I will tell the relative composition. 99% is uranium-238. You can be sure. Uranium-235 is so low that we need to enrich. There are two methods for enriching uranium. One is gas centrifugation method. One is gas centrifugation method. Two methods are there for enriching uranium. Yeah, please.
So, second is nuclear energy production. policy scenario, the share of the world's nuclear power plants in total electricity generation will remain long-term at 12%. According to the IEA, renewable energy sources will be able to serve only half of the expected growth in global demand in 2022. Hydropower provided 17% of the world's electricity generation, which was the third largest source after coal and natural gas. Global hydropower capacity would increase by 17% or to 30 gigawatts between 2021 and 2030. Renewable energy is growing impressively in many parts of the world, but it is still not at a level to reach zero net emission by the middle of the century. Discussion. Climate and energy frameworks target reductions of greenhouse gas emission by at least 40% by 2030. The European Commission has published a new document calling for the EU to achieve net zero greenhouse gas emission by 2050, with NPPs playing a major role in this effort. Therefore, NW generation should increase during this century with a concomitant increase in nuclear energy consumption. Thus, implementing a recycling economic policy strategy that involves recycling waste instead of utilizing primary resources merits immediate attention.
Excuse me, here this point is very important. Please make a special note. Can you please read out this sentence once again, Priti? Implementing a
recycling economic primary resources merits immediate attention.
Yes, please go ahead.
NW is radioactive and requires careful management and
What is NW? What is NW? Yeah, you are following. Go ahead.
decommissioning. In some countries,
What is SNF?
Yeah.
Spent nuclear fuel. Spent nuclear fuel. If it is SNM, it is different. Special nuclear material that has plutonium and uranium 233, plutonium 239. That is very valuable. Special nuclear material SNM is different from SNF. This is spent nuclear fuel. Please go ahead.
In some countries, SNF gets recycled and reused, while other countries simply disposed of SNF as hazardous waste.
Why it is hazardous? Because it is radioactive. Radioactivity, we do not see with our eye. That is why it is more a problem. What we see with our eye, we will have an assessment. It is intense to this extent. Okay, river contamination. Okay, water pollution, air pollution. When we go out, when there are many automobiles, we see the emissions. All those are seen, but radiation can we see? No, that is the complexity of the issue. Radioactivity we are talking about. Please go ahead, Priti.
However, technological difficulties and public opposition force many countries to store their SNF temporarily instead of recycling or disposing of it. The accumulation and storage time of SNF increases by the day. SNF still contains 90% usable fuel. The sensible option is to reprocess and extract the unused uranium and plutonium for recycling into fresh uranium fuel. Currently, most countries that operate nuclear power plants instead to dispose of their SNF in DGRs without further reprocessing. This leads to an increase in the amount of HLW for storage and decommissioning. The management of SNF and NW requires a safe, secure and permanent decommissioning technique.
Please, excuse me. DGR, is it called something like geological repository? Can you please tell us the direct full form of DGR? Is it geological repository? Full form, please. DGR. This is very, very important strategy for managing nuclear waste. Okay, making it, in a, what is DGR? No, 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 no. That is different context. Madam, control, search and tell us what is DCR. Control F. If you type in Google DGR and nuclear waste management, it will talk of some geological repository. What is D? What is D?
Deep geological repository.
Yeah, deep geological reposition is one strategy where America failed. So we are exploring other possibilities. Deep geological repository. Agreed? Yeah, please go ahead.
Two such methods involve the development of deep geological resources and a nuclear fuel reprocessing plant.
Wait. Can you go back? Deep geological repository, development of deep geological repository and a nuclear fuel processing plant. Dear friends, please make a note. Today Priti has presented a wonderful lecture and रुकिए ना, madam, please give me 1 minute. You are not allowing me to.
Sir, only 10 minutes. Only 10 minutes with 60 pages का presentation है मेरा, and you also come.
What can I do? You are trying to kill the spirit of the presentations. You are not.
I'm not trying.
Okay. Let us thank. Okay, I agree. Only one word. The main keywords of the presentation to manage waste. The way forward is deep geological repository as well as spent fuel reprocessing. We have to develop reprocessing strategies to extract the unused fuel. Okay. We accept your concerns, madam, but we are here with a purpose. Okay. I thank Priti for a really very wonderful professional presentation like a scientist. It's scientific. We derived new knowledge from your presentation, Priti. Thank you for devoting your time. But what is missing is, we expected to see some beautiful images of repositing. Okay. We expected to see the flow charts. Where are they? वो कहाँ है? This is flow chart. I am asking about होता है ना पाई डायग्राम.
सर उसने फोन में से पीपीटी बनाई, फोन में नहीं होता, फोटो नहीं होता, अच्छे से कॉपी नहीं होता.
ओ लैपटॉप नहीं है उनके पास. We should give Priti a very big hand. It's very difficult to make a presentation with phone. Yeah, thank you Priti. We thank you, Priti, for putting so much time, effort in preparing. If you have noticed, her presentation is very, very fast. Thank you for the very eloquent lecture. Thank you.